Hello, my name is Margan Limbu and this is my CSCI E-90 final project, automating cloud security audits for AWS. With the growing complexity of cloud environments, misconfigurations such as public S3 buckets or overly permissive IAM roles are common and can lead to data breaches. My project focuses on automating the detection and remediation of these issues to enhance cloud security. To address the common vulnerabilities in AWS environments, I built an automated system that identifies vulnerabilities, remediates issues, and generates detailed audit reports. By using AWS Config, AWS Lambda, AWS Security Hub, S3 buckets, and SNS. My system follows a 5-step workflow: monitoring with AWS Config, finding aggregation with AWS Security Hub, remediation with AWS Lambda, audit reports in S3, and alerts via SNS. Manually identifying misconfigurations across multiple cloud resources is time-consuming and error-prone. This project automates the process by monitoring resource for compliance, automatically remediating non-compliance, and storing detailed audit reports and notifying stakeholders. The main goal is to create a scalable, automated system for cloud security audits. Here's the diagram of system architecture and workflow. AWS Config monitors resources and detects non-compliance. And Security Hub aggregates findings from the config and other resources. After that, AWS Lambda remediates the issues and generates audit reports. And reports are stored in an S3 bucket, and SNS sends the notification. Step 1. Monitoring with AWS Config. AWS Config evaluates all S3 buckets against a compliance rule. If a public bucket is detected, config generates a non-compliant event. Step 2. Aggregation with AWS Security Hub. Security Hub receives the non-compliant event from AWS Config, consolidates the finding, and triggers an alert for prioritization. Step 3. Remediation with AWS Lambda. The non-compliant event triggers the Lambda function. Lambda does the following. Number 1, identifies the public bucket. Number 2, updates the bucket policy to block public access. Number 3, generates adjacent audit report detailing the remediation. Step 4. Storing audit reports in S3. Lambda uploads the audit report to the bucket designated, which is Margan test private bucket. And here's the example of the report, which has timestamp, the name of the remediated bucket, the remediation action, and the status. Step 5. Sending notifications with Amazon SNS. Lambda sends the report summary to SNS topic, which is Margan config alerts. SNS notifies subscribed stakeholder via email or SMS. And here's the image of the SNS email. To set up the AWS config, I logged into the AWS console and searched for AWS config in the search bar and clicked on it. Since this was my first time using the AWS config, I clicked on Get Started. After that, I selected all resource types with customizable overrides to ensure AWS config tracks all relevant resource types for vulnerabilities. And for the default setting options, I enabled the continuous recording option because it ensures the system records changes as they happen, which is crucial for real-time security audits. After that, for the delivery channel, I had to create a bucket and create an SNS topic. After configuring the settings for the AWS config, I had to add the rules for the AWS config. So these are the rules for the config, which are S3 bucket server-side encryption enabled, S3 bucket public read and write protected, IAM user multi-factor enabled, EC2 instance, no public IP, RDS storage encrypted. After reviewing the selected settings, I clicked on confirm, and the AWS config setup was completed. After the AWS config was set up, I went to the rules which was located on the left hand side, clicked on it, and this is the screenshot of the compliant rules, and the second screenshot is of non-compliant rules. Step 2. Setting up AWS Security Hub. The objective of the AWS Security Hub is to centralize security findings and integrate them with the AWS config. To enable AWS Security Hub, I navigated to the search bar and typed in AWS Security Hub and clicked on it. After clicking on it, under Security Standards, I enabled the relevant standards. The standards allow the user to identify security issues across the resources. After that, I clicked on Enable Security Hub option to complete the Security Hub. After that, I had to integrate the Security Hub with AWS config, so I navigated to Security Hub, and after that, I clicked on Integration on the left hand side and clicked on AWS config and clicked on Enable Integration, just like shown in the picture. After integrating AWS config with Security Hub, AWS Security Hub will now collect security findings and display them in the findings section. We can also manually trigger security findings by using the AWS config rules. For example, to check for public S3 buckets or overly permissive IAM role. As we can see in the picture, the Security Hub already has a finding for S3 bucket, which has public access, and it's recommending us to block all the public access for better security. After clicking on the security findings, we can see that the status under compliance, the status has failed because the S3 bucket should never have the public access open. Step 3. Automate remediation with AWS Lambda. The objective here is to automate responses to security findings detected by AWS config or Security Hub. So I use Lambda functions to automatically respond to security issues. For example, if an S3 bucket is found to be publicly accessible, it can trigger a Lambda function to make it private. Or if there's a non-compliant EC2 instance, Lambda can notify the team and shut down the instance. So I navigated to Lambda function and I clicked on Create Function to create a new function. After that, I chose and I clicked on Author from Scratch among other options, and in the function name I named it Remediate Public S3 Bucket. After that, I selected Python 3.13 from the drop-down menu and selected Create a new role with basic Lambda permissions, and after that I clicked Create Function, just like shown in the image. In Lambda, under the Code tab, I typed in the code and clicked on Deploy to save it. Here's an image of the code I wrote in Python. After writing the code, I clicked on Deploy and saved it. After saving the code, the Lambda function needs permission to interact with S3, so it needs to be able to change the ACL of the bucket. So I added permission to Lambda by navigating to Configuration tab, Permissions, Execution Role, clicked on the role name, Remediate Public S3 Bucket Role. After that, I navigated to the Test tab in Lambda console and created a new test event and saved it with the following JSON. As you can see, the JSON code in the picture, that's for the test event I created. After I ran the test, the Lambda code successfully remediated the issue, and you can see status code 200 with the body message saying successfully updated the policy of the bucket. I wanted to receive notifications about when Lambda runs, so I created a new SNS topic. I navigated to SNS console and clicked on the topics, located on the left side of the menu, and clicked on create topic. After that, I selected the standard as the type and named the topic S3 bucket remediation alerts. I left the other options with the default value and clicked on create topic. After the topic S3 bucket remediation alerts was created, I clicked on create subscription button. After that, I chose email as the protocol and entered my email address. And after that, I clicked on create subscription. As you can see in the picture, my email address is pending confirmation, so I have to go back to my email account and look for the email from SNS. So in this image, I received the confirmation email and clicked on confirm subscription. To confirm the subscription, I had to copy the URL and paste it into the subscription confirmation URL box. After the confirmation is complete, we can see that in the subscriptions, my email has been confirmed for S3 bucket remediation alerts. And after that, I started getting emails from SNS. After confirming the SNS, the next step was to create an audit report. The report will provide a summary of findings from AWS Config Security Hub or the scans. In addition, it will include details such as timestamps, resources checked, compliance status, and remediation actions. I'll be using one of the buckets that I created earlier to store the audit report. So I navigated to AWS Lambda console and selected the existing Lambda function. After that, I modified the code and added the code to store the audit report in one of my bucket, which was Margan test private bucket. After making changes to the code, I clicked on deploy to save the code. Before I created the test function in Lambda, I had to make some changes in one of the IAM roles that was used by the Lambda function. So I navigated to the IAM role and clicked on the role assigned to the Lambda function and added the S3 put object permission to the IAM role. So the way I did was I attached the new policy for the role and saved it. As you can see, the JSON code I put for put object permission. After updating the IAM policy, I went back to Lambda function and used the test event. And as you can see, the screenshot shows the status code 200, which shows that the Lambda function was good and the test event was successful, and the audit has been created in one of the buckets. And to verify the audit, I navigated to the S3 console and opened the bucket that was designated to store the audit reports. So the audit reports was saved in the bucket, and when I clicked on it, I was able to see the details of the audit reports. As you can see, the report has the timestamp remediate underscore bucket and remediation actions and status. After that, I got a notification in my email address saying that the audit report was saved successfully.